Hello, everyone. Thank you so much for coming. We, three of us, it's my co-presenters. I'm really happy you made it. The name of this session is about your data, your model, for your business with privacy-preserving, privacy-safe capabilities. And no surprise, you will see the presenters. I am Nelly Porter. I'm Director of Product Management in Cloud Security, working on, no surprise, confidential compute and encryption security platform. With me, let us welcome my partner in crime, Amit Patil, who is the Engineering Director of the same area, owning this in Google Cloud and Google overall, and Todd Moret, my partner as well from Thales, that will be talking and helping us to explain what our partners can do in this space to help to protect your data and protect your models. Amit, please start us off. Good luck, my dear.
Thank you, Nelly. Good afternoon, everyone, again. So you already heard today's keynote, right? It was all about AI. And no wonder, our session is also going to be about AI. And last year, just 6 months ago, when the first Google Next talked about everything about AI, I think I was checking out of the hotel a day earlier, and one of the customers said he can only take as much of AI. Right? They heard too much of AI. But fast forward now, it's been just 6 months, and everybody is clamoring to get onto the AI bandwagon. Right? Everybody wants to do. People cannot get enough of the AI action. And in cloud, we see our customers in 3 big categories. I think first is the folks who are producing models and who own the models. These are really the big guns. They're spending millions of dollars on training the foundational models, getting them out, and also hosting them for inference as a service. The second bucket of customers are the model tuners, who are now taking these models from the model producers and model owners, or they're taking the open source models and they're tuning them with their own private data sets, trying to make them more accurate, more focused, more topical, and so on. And the third set of customers is the bulk of the customers who are the model consumers. So these are the folks who are using the models as a service, doing in-context learning, or RAG, as they call it as well, and using these models in their applications to enhance productivity. But across all these categories of customers, what we see is, number one, the models and data are super critical, right? The models, both the code and the weights, are really the crown jewels for everyone. Similarly, the data also becomes super important, because even the tuners and the consumers are using their own private data to augment and make the models more effective. So people are super concerned about both the privacy and security of the models and the data. Similarly, because they have spent millions of dollars in training this, they are concerned about confidentiality from the cloud provider. This is top of mind for most customers today. So these 3 things are common across all 3 segments of customers. And as you see, a lot of these, the AI customers come from a variety of industry verticals, from financial services to healthcare to government. They are using this to detect frauds. In insurance industry also, they're using it to make their products much more effective and differentiate their product. And the key use cases that really stand out are, number one, enhancing productivity. That is top of mind for everybody. Second is differentiating themselves from the competition. And the third use case is really chatbots or agents that everybody has been building to make life easy, be it for customer support, for sales, as well as things like document summarization. These are the most important use cases that we see across all the industry verticals. And across all of this, data confidentiality becomes super important. And not only confidentiality, just protecting PII data is just not enough. Only that much simply does not meet the bar. People are looking at how can they collaborate, how can data from multiple sources be merged together to make the AI models more effective, and they want all of this to be secure and in a privacy-preserving environment. And this is where confidential AI really comes into the picture. So forget AI for the moment, right? So where do we store in your homes, where do you store your most prized possessions? If you have valuables, if you have crown jewels in your house, where do you store them?
You're asking me?
Yeah, why not, Nelly?
OK, I will go to the bank, I guess.
Yeah, Nelly has seen the slides, right? So typically, you would store them in a bank locker, right? In the modern world, you also have digital lockers for your high-value documents and so on. But the locker, the bank locker, comes with a few characteristics, right? Number one, you need to declare to the banker what you are storing in the locker. The second part, the banker also has a key to the locker. Without the banker using their key, you cannot open the locker, right? And third, they're not accessible 24/7. You need to go there only during banking hours. And fourth, and the most important limitation there, is the size of the locker determines how big of a valuable you can store. So the larger the locker, larger your valuable, the bigger the locker you need. And this is restriction. What if we said that in the AI world, your crown jewels, your model, their weights, and the data that is used to train can be stored in this locker in your data center, and it does not have any of the limitations. The banker, which is the cloud provider in this case, does not have access to your keys. There is no limitation on size. You can lift and shift everything. And similarly, the digital locker is accessible 24/7. Right? And this is exactly what confidential compute brings to the table as a value proposition. We have the VMs, and every virtual machine, the memory is encrypted at runtime by a key that is generated by the underlying processor. Not only that, these keys are ephemeral, and they keep rotating and changing. Neither are they exportable. So the banker, the cloud provider, simply does not have access to the keys. What this ensures is, as a cloud provider, from the hypervisor layer, we absolutely have no access to the data. We cannot peek inside the VM. Even if we peek, the memory is all encrypted. We have no access to it. And this is scalable. You can scale up to 224 vCPUs, 1 terabyte of memory, which should be more than enough for lifting and shifting your applications and moving them to a confidential environment. And all of this is backed by hardware guarantees. Right? The processor is the one that is generating all of this. Memory integrity is assured. And not only that, Google adds its own set of value add on top of it. We give you guarantees and assurances by both transparency as well as measurements on the entire stack, low-level stack, right from the hardware, that is from where it is sourced, our supply chain guarantees, as well as the firmware, the operating system stack, and the entire operating system kernel. Through transparency, we give you guarantees on all of the low-lying stack. This, coupled with storing data at rest using encryption. So remember, Google Cloud was the first cloud to provide encryption at rest by default, by Google default encryption. And we have now taken it to the next level with Cloud KMS, which allows you to bring your own keys and get assured single-tenant keys with which you can control the encryption of your data. But not only that, we have now taken it to the next level. The same technology that is powering these VMs, we have now introduced in our internal infrastructure. We now have confidential hyperdisk, which is now in private preview and accessible for all of you. And this technology is also powered by the same goodness of hardware-based guarantees, where our internal infrastructure nodes are providing a confidential environment where all keys are handled. Similarly, all encryption and decryption is done in a secure way, with Google having no access to the keys at all. And this comes with everything, the same guarantees. The keys are not exportable, and this product is there. Combined with the confidential VM and the confidential hyperdisk, now you have end-to-end guarantees on the confidentiality of your data in use as well as data in rest. And this is how the end-to-end picture looks like. Right? In the AI world, we are now taking it a notch further. With our partners, NVIDIA, we are now bringing NVIDIA H100s in private preview in confidential mode. Again, the same goodness, the same technology, with the additional guarantees that the PCI bus is also protected. This ensures that communication between the CPU and GPU is encrypted and protected, and it also happens at line rate. So there is no performance degradation at all as a part of this. All this forms the basis of our confidential cloud platform. At the bottommost layer are our infrastructure services, which consist of virtual machines, both on the AMD as well as Intel platform. Intel, by the way, is also in public preview, Intel TDX, available through all regions, the AMD machines and Intel machines in select regions, as well as our GPUs. And we've also brought Intel AMX, which is Intel's version of accelerators, to the market as well. This, coupled with our attestation service and the confidential hyperdisk, forms the basic underlying infrastructure. On top of it, we have our confidential services. This consists of confidential GKE nodes, where you build your DIY AI applications. Right? We have confidential data proc that consists of MapReduce, Spark, Hadoop, all of this which is needed for processing applications data at scale. And on top of this, we've built value-added solutions or applications like confidential space that allows you to do secure multi-party exchange, as well as our confidential AI solutions. This now powers the entire infrastructure, that is Google's confidential cloud infrastructure. On top of it, we have all the goodness of AI. We have our model garden, we have our AI platforms, as well as AI solutions, and you can bring your own generative AI-powered agents on top of this platform, or you can use Gemini Cloud Assist out of the box. Right? And all of this is available today for all of you to use. Next, I think we'll have Nelly walk you through how we can use Gemini Cloud Assist today with a very nice demo to follow through. Over to you, Nelly.
Thank you so much, Amit. So, thank you. And we will go from the bottom of the stack to the top of the stack immediately. So we introduced today at Next what we call Gemini Cloud Assist, and its ability for us to help our IT admins, our cloud admins, our platform admins to deploy their applications in GCP. And it's not an easy task. If you will add security, compliance, privacy, regulation, all of that, it's complicated. And for our admins, it's always challenging. So Gemini Cloud Assist is trying to help on every single way to explain and answer Q&A questions from our admins. Let me show you one experience. And we're talking about Bob. Bob is coming to deploy application to GCP. So Bob's application is about matching users with specific traits to whatever they're trying to collect about these users to inform their study, their medical study. So information is very sensitive, no surprise. Definitely have plenty of regulations attached. And our Bob trying to figure out what to do with GCP. So let's run the demo. No surprise, it's modern app. It's already in containers, so they come into GKE, our managed Kubernetes engine, and we'll try to create Kubernetes cluster. So everything is normal, very easy to go. They going and create cluster. No surprise, because it's so much confidentiality. The name of the cluster, confidential cluster. And now they're going to security tab. In security tabs, they will see the opportunity to enable confidential GKE nodes. What is that? Explain this feature. And Gemini Cloud Assist explained very nicely that it's the feature that enable a little more data security, provide help with regulations. And then, again, our admin will ask what machine family is actually supporting and how to deal with very high performant, high QPS entrance. And again, Gemini capable of answering all of those questions. But finally, Bob will ask, okay, is it really protect my data in use? And Gemini will answer yes, and cite the sources to make it very grounded. And the final things, again, Bob will say, it's healthcare app. What do I need to do? And Gemini will help to identify specific regulation regimes like HIPAA or maybe high trust, and also recommend confidential GKE as a way to address those regulations. So by the end of the day, Bob is convinced and going to create confidential GKE cluster. And this demo, it's all very quickly. but it's not enough. So again, Bob is digging into one of the nodes. All nodes in this confidential cluster is confidential, and trying to figure out, okay, how they will prove to regulators that it's really confidential. So they're coming to the logs, and they're like, I want to ensure that my data didn't change. It's not tempered. Something about integrity here. And they found 3 log entries talking about integrity. So let me, said Bob, navigate to those entries. And they found some entry with very interesting, applicable name. It's called Self-Launch Attestation Report Event. What is that? So again, Bob copied that to Gemini, and Gemini answered very reliably that it's the way how you would be able to attest your environment, and it's the way how to collect all of those claims and present it in single report. And after that, again, Bob seen some self-policy, what is that? And Gemini figured out, okay, it's part of the same log event, and also explain every single property in this policy. So right in line with my operation, Gemini Cloud Assist helped me to accomplish my task. And you will see the same thing done in very critical, not reversible decisions. For example, when you're coming and creating encryption, in one of our sessions, we will show you how Gemini Cloud Assist will help you with those decisions when you have too many options to choose, and you need to figure out which one to take, or why you need to choose one specific option versus another. So we only started in Gemini Cloud Assist, but something we'll learn. And this learning is what we're trying to explain to you today. If we will step back, for Gemini Cloud Assist, we had these interesting challenges for ourselves. We needed to take all of those different data sources, structural and unstructured data. We need to prepare it in some way, shape, and form, and do what we called prompt augmentation, or RAG, or in-context learning. And why we decided to go with RAG in-context learning? Because of a few very important reasons. For smaller data sets that we had in our possession, to train our Gemini Pro would take enormous amount of time. You need to run those gigantic models 10x times to be able to remember anything from your smaller data set. It's super expensive for all of you and us. And the second one reason, and this very important reason, we innovate very quickly. We're adding those features and those capabilities in our products. We can't retrain, fine-tune the model again and again to provide this information. So giving this, again, runtime updates with this information becoming critically important. And RAG, or in-context learning, it's the way to go. And it's what we learn ourselves. One additional thing that we learn also, no surprise, that to make all of that very efficient, no surprise, you need to deal with a lot of data. And this data needs to be collected from different sources. It needs to be augmented, matched, cleaned. It needs to be deduped with MapReduce. It needs to be, again, done everything that you usually do with your data pipeline. I read once, somebody said, any LLM app is data pipeline app. And it's absolutely true, because dealing with the data 24/7, it's complicated. But I'm sure all of you have done this in the past. It's not a new problem. It's a problem that we know how to solve. And having confidential products, like confidential data proc that has managed Spark and managed MapReduce, will help you to protect this data end to end. So, but if I will step back for RAG, or with inference, or for tuning, or for training, data preparation and data pipeline is a critical step. And protecting this data with confidential environments and encrypting this data at rest is absolutely critical. We also introduce what we called, not in addition to confidential environments in VMs, in GKE, in our cloud data proc or data flow and other services, we also introduce this confidential mode hyperdisk, when you can write your data very efficiently and read it from the same disk attached to your nodes in your confidential GKE cluster. So then you will save your performance and the time that you deal with, again, upload and download your data. And this data and those, again, persistent disks will be encrypted at rest utilizing Cloud KMS capability. And Cloud KMS offer all kind of keys for your decision. We offer software keys. We offer hardware keys with HSMs. It's FIPS 140-2L3 for some of you in the audience that understand these magic numbers. And it's, again, it's very important keys because we also attest those keys that they always and always hold in HSMs. We also have ability to encrypt your data with external key management. And Todd with Thales will talk about this capability. When we encrypt your very viable data and model off cloud and bring it when needed to operation. So as I mentioned, in every single step on the way, when you're dealing with inference, tuning, or in-context learning, all of those aspects of data protection, data encryption, and data in use and model in use capability is critical. And we have some solutions for you. So some inference can run with smaller models on CPUs with this interesting extension that Intel introduced together with confidentiality. So confidential CPU, it's the special extension in Intel called Trusted Domain Extensions, or TDX, and another extensions that Intel introduced called AMX. It's Advanced Matrices Extension, and it's allowed to use CPU for some really cool, interesting inference jobs, so you don't need very expensive and very sophisticated GPU accelerators. We're also bringing to the market combination of confidential CPUs and GPUs for your models and your data. And for some of you that privacy of the model is not as critical, TPUs with combination of confidential environment will be fantastic choice. And now I will bring you to very complicated demo. Please be with me. So I'm trying to bring all of that together. You remember my Bob? So Bob figured out what to do with confidential GKE. He will be part of my use case. And now I will have Alice. And Alice is a wonderful person because they're trying to fine-tune models that they download from Hugging Face. So imagine the use cases. That Alice downloading from Hugging Face model. I picked Llama 2.7b for fun. And after that, encrypting this and sharing it with Bob. Because Bob, no surprise, wants to use this model and do inference on this model. So when Bob is accessing this model, what Alice wants, first of all, she doesn't want to pay for this inference. The second, she wants to ensure that model is not tampered with and continue to be private. What my Bob was interested in, no surprise, that his data and everything that he will do with this model is going to be also confidential and not exposed to Alice, and probably Google Cloud as well. So let's see how it can be done today. And as I said, please be with me. We will go through multiple stages. Stage number one, Alice is dealing with Hugging Face. So it's, again, no surprise. You have CLI in Hugging Face, so you will, and it's not fake, by the way. It's all real. So Alice is downloading the model. And as you will see, it's Llama 2.7b model, good model to do inference for Bob. So we're ready to go and use this model. And again, as Alice downloaded that, so now she's ready to fine-tune this model and do what's necessary to make it very special for use cases that Bob supports. So again, let's assume that it's what Alice did. And she set up her own projects. She created the keyrings to encrypt this model because she needs to bring this model to GCP. And she created the special key that she associated with this storage bucket. Okay, so this key resource and key is done. And now Alice, after fine-tuning, definitely she needs to tar all the files, no surprise, too many files. So we will tar it. And again, we will upload it to GCS bucket. So now we have a wonderful model, fine-tuned, sitting in GCS bucket, fully encrypted, fantastic. So now we're switching to Mr. Bob. And because Bob figured out, thanks to Gemini Cloud Assist, that confidential GKE cluster is appropriate, they created confidential GKE nodes with one single flag, enable confidential nodes, done. So as soon as confidential GKE cluster is created, everything is great. They're obtaining Kubernetes credentials to ensure that Alice will have limited access to their things. And set up the YAML for the pod with 3 containers. First, they need to ensure that pod will finish on GKE confidential node with this specific label, and they have 3 containers in the pod. Init, this init container will download the model from Alice storage bucket to GKE. The second one is the inference server that will do the inference. And no surprise, the third one is web UI, because Bob will access Alice model only through API and web UI that Alice allows them to access it. It's not, again, those notebooks that you love, because then you have full access to the model. So we have web UI that we enable as a third container in our confidential GKE node. Everything is set up. We have fantastic YAML. We will deploy this pod to GKE. Let's wait a little bit. Even in demo magic, it's taking time. And after that, we will ensure that our pod is up running. Yes, we have our pod with our 3 containers, everything in place. Let's ensure that our Llama 2 7B is there as one of the containers on our confidential GKE cluster. Yes, we have that. Through our metadata, we can see that everything is up and running. So inference server is ready. Web UI is deployed. Our model is plenty, and we initialize all of that. The last one, we need to port forward to access this inference server. So Bob would be able to do it, and now you will see the results of this labor. Let's test our model. And what we will do, we will ask it, what is confidential computing? No surprise, huh? And Llama will think really hard and will say absolutely properly that it performs on sensitive data without revealing this data. So it's the way how you would be able to orchestrate the whole entire story about protecting the model, keeping the model yours, and protecting the data, keeping this for yourself, and also ensure that it does what it needs for your business. And now let me introduce Todd Mura, who is VP of Thales, working with us on all of these fun projects. Todd, please. You're so welcome.
Thank you, Nelly, first off, for inviting Thales to be here. For those of you that don't know who Thales is, we're a large global company, over 77,000 employees. We do a lot of different things, but cybersecurity is a big part of our business. And been working with Google for a long time at protecting data within Google Cloud environments through external key management, as well as confidential compute environments with ubiquitous data encryption. So strong relationship, and we're getting ready to apply that relationship extended to AI as well, too, protecting models, training data, and the inferences from the AI data. Before I get into some of the things that we've been thinking about doing together, I just wanted to show some of the metrics that really stand behind what Amit said earlier. At Thales, we do an annual data threat report where we ask over 3,000 security professionals and executives around the world about a lot of different things. And this year we talked about AI. And about half of the respondents, probably half of the room here, were concerned about data leakage when it comes to AI, creating code, regulatory compliance, data privacy, as the beginning of this talk, as well as lack of control. And that's where encryption and key management can come into play in terms of protecting your data as you go into this AI world. So at Thales, we do a bunch of different things within cybersecurity. We support protection of applications. We do that through DDoS, botnet, API security. We have a whole slew of encryption and key management solutions to protect data at rest, in use, and in motion, as well as identities. We protect human and machine identities, and that all kind of works together. What we're doing, working with Nelly and in Google Cloud, is we're looking at how we can help protect information as it goes into AI information that goes into confidential compute environments, so confidential AI. So Google provides the isolation through the Intel TDX that you heard about. Thales provides the data protection, the security, the encryption and key management. And we're working with Intel to be a third-party attestation for the software hardware, making sure that that hardware and software is what it should be, and we won't release a key to run in that confidential compute environment unless Intel says we should. And we're able to use that in an AI world by being able to make sure the training data is protected as it goes into those environments, making sure the model, when it runs within a confidential compute environment, is correct and valid, and then from the inferences that come from that model, being able to protect those inferences on that data. So a lot of great things happening in collaboration with Google Cloud. That's all I had to say was 5 minutes, but if you're interested in the Thales Data Threat Report or more about what we do with Google in terms of protecting information, happy to talk after this session or look me up on LinkedIn. Nelly, back to you.
Thank you so much, Todd. Appreciate it.
Thank you.
So Todd did mention one interesting project that we ran together. It was ubiquitous data encryption. And the idea here is no surprise. You need to encrypt data off cloud, but how you will figure out that you would be able to decrypt it to their secure environment. So ubiquitous data encryption, despite of complicated name, its ability for us to provide policy attestation statement to Thales systems, so they will validate these security guarantees that we offer and enable to decrypt this environment or this data to pass it to confidential environment. So it's a very interesting project that we've done, and thank you so much, Todd. It was really, really fun to work with your team.
I should have said that this is in private preview right now, what you just described, Nelly, and we do have several customers interested in checking this out, so willing to work with them in private preview and hopefully have GA very soon.
Thank you so much.
Thank you.
Okay, so let me kind of complete the story here. So what we introduced today and talked to you, it's about confidential AI. And confidential AI is very important industry effort. It's not only Google, it's also every single company, every single cloud provider contributing and working on confidential AI. And its ability for us to protect your data, to protect your model, and provide attestation, guarantee that what we do, we actually make everything that we promise reality. And this attestation, this cryptographic statement that we offer you, your customers, or your regulated entity is incredibly important to complete end-to-end story. We also, in Google, are working on multiple confidential AI projects, no surprise, focusing on both confidentiality and integrity of your data and the model. And one additional thing that's critically important to us as the industry, as a people, as humans, it's usability. We want to ensure that security technologies that we use, it actually will be usable. And that's why usability and performance is so important for us when we offer confidentiality, integrity, security and privacy, and meet regulated requirements for you and for your customers. Thank you so much Here are more sessions that expect, again, your participation. Please join my team. There is plenty of conversations that we will have about confidential compute. There is very interesting effort going on in industry called third-party cookie deprecation for ad tech company, when a lot of work is done to do privacy-preserving ad processing. Please come to this session as well, and we will have plenty of conversation about what we do in key management environment as well.
Thank you.
Our goal to. Thank you so much for coming. Really appreciate it.